video thing. All right. Okay, well, thanks for coming today, everybody. I appreciate you being here. I know you have a lot of other places you could be in the world, so thank you for being here. So we'll start with that. So I'll dig in here a little bit about Hedera and myself. So I come to this space as an educator. I used to teach elementary and junior high school and high school in Canada, which is where I'm from. And I noticed working in crypto and Web3 for the past 4 years that it's very confusing for people. There's a lot of terminology, and people get lost in it. Like, it really gets in the way of you actually doing the creative things you want to do. And so one of the things I love is supporting people to be able to do those creative things. So hence this talk. So let's start with that. Yeah, and in that vein, I have in my pocket here, or the other one, an acorn that I got in the park before I came here. Because we all got to start somewhere, right? So take this as a sign, like, no matter where you're at, everything's okay. Let's start there. So what is jargon? So there's developer jargon. You all know that. You learn a new language, it changes. Everything's not always the same. There's similarities, but things change, right? But every industry has jargon, Web3, Web2, all this stuff. There's words in here from education, from plumbing, from, what else is in there? Teaching, metacognition is a word from education. And yeah, so this stuff, you come into a new industry or a new thing you're trying out, it's really hard when you come up to it, and it's hard to ask questions about it because you feel like you might be an idiot for doing it. So again, acorn thing, gotta start somewhere. So don't be so hard on yourself, please. Breaks my heart to see that. So jargon gets in the way, creates barriers to effective communication, makes people feel left out, and there's like a top-down sort of thing where people who know the things and don't know the things, like haha, like that. And that's not welcome for anybody. Nobody wants to do that. You can't learn like that. To be able to learn, you have to feel open and safe, and you'll do a heck of a lot better than if you're just coming and feel defensive. Oh, you can look right here. All right. So in this presentation, we're going to take a look at transactions right from the base level of Web3 and looking at it through Hedera lens and what things look like. So let's get started here. All right, so if you're confused already, that's okay. This is the first one, but that's all right. So we can start here, and we'll go a bit at a time. It's going to build up as we go. So transaction on a chain. So Hedera is not a blockchain, but it's similar. It's a distributed ledger technology. And what that means is a node, a network of nodes. In the same way as a blockchain works, it's like having a database that is all transparent and secure, and people can check in with it from different points. So it's decentralized. So within all of the different DLTs, you have transactions and TPS, or transactions per second. So each chain has its own way of doing transactions and how they count that, but the speed is consistent, and TPS is a nice thing to know, because if you're processing something like micropayments, or you want to know how quickly information is moving across your app, then you can find out through the TPS. Finality, so when transaction is completed and it can't be reversed or revoked, canceled, or changed in any way. So a thing that happens on chains is immutability. So immutability means that things can't be changed. So that's what makes Web3 and these networks like this really reliable for information. It's nice to be able to have that, so you know if you want to track something in your database on a network like this, that it's going to be really solid, and you can check in on it later and know that it's been confirmed by multiple nodes that it is real and good information. So didn't start that way. So some of the stuff you're already familiar with. Starting in the 70s, when we had analog, moving into digital, and then internet, 2000s, and then the trust era. 2009 was when Bitcoin was invented. And so in time, that was like a layer one. So it was like the first generation of a distributed ledger technology, a Bitcoin. And in time, other ones have been developed. So we've got Ethereum, you may have heard of that, which is another layer one. And Polygon, for instance, which is a layer two built on top of Ethereum. And Hedera, which is a layer one as well. So it's outside of Bitcoin and Ethereum, it's its own thing. It operates differently. But basically, the Web 1, Web 2, Web 3 thing, the easiest way to understand it, I think, and that little arrow is making me a little twitchy. There we go. Move it out. Nope, not like that. Okay, cool. So yeah, Web 1, mostly static. I was on the internet in 1995 in grade 8, and I remember this. You could just like check on stuff, read it, and that was about it. Then when Web 2 came out, then it was read and write. So you'd be able to dig into content and comment on it and get involved. You could be a creator, but you couldn't own the content. You'd upload it to social media, for instance, but they would own it, right? So it was on their servers. And then Web 3 is like that, but also with decentralization as part of the DLTs. So there's a lot more possible when things are owned and distributed by the users. And that's what I'm a big fan of. I really want to see that power distributed so everybody can be treated as equal people in the world. That makes me happy. So decentralization. So it's disintermediating that power across it. So you take out the person. So say it was a bank and you have finance, you would have decentralized finance. So instead of having to send money through a bank, you just send it directly to your friend. So that is really helpful because, well, it makes things a lot simpler for people to be able to own their own money and to be able to access their own information in ways that work for them. So I'm a big fan of that. That's why I'm in this space, honestly, is to help make things be more decentralized and decentralized power. So yes, distributed ledger technology. So it is decentralized, and there's a number of different DLTs. We call Hedera a DLT because it's not a blockchain, as you'll see. It's not built with blocks on a chain, which you may have heard of them that way. And it's a bit different. So it is, like it says, Hedera is a non-blockchain DLT. Okay. They're a key component of Web 3 because of their qualities. So you can see the difference here between Web 2 and Web 3 with the centralized versus decentralized nature of it. It makes a lot more possible with security and transparency especially, because you don't have one single point of failure, or potentially. So blockchain, so that's a database that is done with blocks in an order, and the transactions are grouped together in a block, and then they get processed on the blockchain in time, which makes things possible, but it's got some speed limits, essentially, just by processing. So Hedera is not a blockchain again, but it is a distributed ledger technology, so it's a DLT. It's a bit different, and I know that can be confusing sometimes for folks, and that's okay. I spent an hour and a half on the phone doing support for crypto before, so I know what this stuff is like. It can be confusing, and that's okay, like I said. Permissioned and permissionless. So you can have private distributed ledgers that require user access from an entity that controls the network, or you can have permissionless where it's accessible by anyone on the network. So that's a very different thing. Right now, Hedera is a public permissioned network moving to public permissionless. So right now we have 27 nodes that are part of our governing council. That includes companies like Google and IBM and Shenzhen Bank and a number of other companies, universities around the world. And they help secure our network. In time, there's going to be community nodes, and we'll move from a permissioned public network to a permissionless one. And that's going to be helping decentralize things more. So that's something I look forward to. So fiat currency and cryptocurrency. That is a confusing thing, because when I joined this space to work in, like I said, 4 years ago, I didn't encounter the word fiat either, other than the car. So I was just like, I don't know what the thing is that isn't crypto, but I kind of know what crypto is, sort of, I guess. So, but in time and figuring things out and feeling like, I think it's maybe because I'm coming from being an educator, feeling like I can be the stupid person, even though it's just if you don't know something, it's like, it's okay. Just ask a question. But again, for the receivers of said questions, you got to feel safe to ask. So be nice to people is the point, I guess. HBAR. So our token within our ecosystem is called the HBAR, and it is energy efficient. We're actually carbon negative within our network, which is very different compared to some other Web3 ecosystems like Ethereum and Bitcoin and others that are based on those, because they take a lot of energy to secure the network. We have a proprietary algorithm called Hashgraph, which does things differently in a way that takes a lot less energy to do. So that makes things a lot better. And then we also have carbon credits that we purchase to keep it down even further. So yeah, like I said, carbon negative network for Web3, which is really great. And we specifically work in enterprise, but open to community too, of course. A white paper. OK, so this is starting to get more into the terms that are specifically related to Web3 and crypto. So a white paper is when somebody makes a proposal of a new network, essentially decentralized network. Then they will put up a white paper and the terms and how it's going to work and the rules of it, essentially. So you can find the original Bitcoin white paper online by Satoshi Nakamoto, and nobody knows who that is. It's a bit of the legend of this space, and that can be fun to read about sometimes, but yeah, no one has ever stepped forward to say who it was. It just was published, and then it kind of disappeared from forums after that. Layer 1. OK, so like I was saying, Ethereum, Bitcoin, and Hedera are all layer 1s. So that's something where the transactions are secured on that network without relying on any other network. Now, things can be built on top of that. Whoops. There we go, Bitcoin and Ethereum, like I was saying. So there's a lot possible with these two. Bitcoin was first, Ethereum was afterwards. They're two separate networks. And then we have some called layer 2s, which are built on top. Hedera, like I said, is layer 1. So we have a token service, consensus service, and smart contract service, which uses Solidity, which is a language for smart contracts, which will be something we look further into later. Smart contracts, so if that's not familiar, that's OK. And there is much more to do with that because you can also use the Ethereum virtual machine to bring in contracts from other Ethereum-based networks through the Ethereum virtual machine. So the smart contract service is compatible with that. So if you are already familiar with some Web3 things like that, then that's a great place to start because you can just bring over your contracts. Layer 2. So like I was saying, that is built on top of another one. It's similar to how it works on layer 1, except you have to use all the base foundation of that, the securing of the network, done on layer 2. Bitcoin Lightning is an example of that, where it speeds up the transactions because it can take a long time for a Bitcoin transaction to work. And it takes a lot of energy. So Bitcoin Lightning Network is faster and makes things a little bit easier for cheaper microtransactions. Yeah. OK, layer 2. Yeah, note that layer 1s, the scaling limitations need to do that because they can only do so much because they have the limitations by how they were built as determined in the white papers and how the community does this. But Hedera, because it's got high native speeds, it is able to do this all on the layer 1. OK, further down the rabbit hole here. Consensus and consensus mechanism. So a consensus is getting agreement for decision making. This happens when you're talking to people. You come to an agreement together. That's consensus. So in DLTs, including blockchains, but not exclusive to, consensus reached when all the participants agree on the state of the data. So that all the nodes, they match. So the information is the same everywhere. But every chain does it a little bit differently. So a consensus mechanism on Bitcoin versus Ethereum versus Hedera is different. And that's as determined by what's in the white paper, essentially. There's proof of stake. So that's using the ensuring fairness by the staking of the coins. And then there's proof of work. So proof of stake is what Ethereum is. And then proof of work is what Bitcoin is. But as you see, the one on the right, it requires large amounts of energy to do that. And Hedera is doing things a little bit differently, where we have something called Hashgraph. And that uses gossip. So I always imagine this like if you live in a small town like I do, there's actually 273 people where I live. And as you can imagine, gossip can go around. So if that's all happening, and then there was like a newspaper reporter who knew all the gossip, they were on top of it. So they were reporting on it. So there's the gossip layer, where the information is shared node to node, and the information from the parent nodes is also included in that. And then the gossip about gossip layer is the history of that. So you're able to be the newspaper person and search the whole what's been happening in the small town, except it's all the state of transactions. Yeah, so like it says right there, what are you talking about? I want to share. That's the upside down stick man there. So yeah, that's gossip about gossip. And that's how Hedera does it. along with something called virtual voting, which I'm not going to dig into too much here, but because it's a different sort of algorithm, it makes it so we can have faster transactions for cheaper and with less energy. So, which is nice. It's, again, why I'm in this space. I'm really into like nature and stuff. I want to do good in the world. So Hedera helps me out with that. And here we are, Hashgraph. Okay. So it's basically gossip about gossip, like I was saying here. It's fast, reliable, and tamper-resistant agreement making suitable for various applications and decentralized networks. If some of this stuff is confusing for you, I'm going to be available afterwards if you want to ask questions too. We can connect, I think, through the app as well. So if you have questions there, I'll be checking there too. Got 11 minutes left. Hedera is the greenest blockchain. So as you can see, it is 1,000+ times less energy than Visa per transaction. So as you're designing your decentralized application, that is something that you can really rely on to be part of your design, to be something that's helpful for the planet rather than hindering, making things worse. A Merkle tree. Okay, so this is part of the data structure behind how these networks work. There's leaf nodes, non-leaf nodes, branches, and the Merkle root. So the best way to show you that, I guess, is through an image. And something I thought would make sense for this audience was, an Angela Merkle tree. So yeah, as you can see, there's different ones on the bottom, but it all goes up. And so the information is shared throughout that network through a Merkle tree. And immutability, so we covered that a bit earlier. That just means not being able to change the network state. So once it's stored in the network and consensus has come to be made, then it is immutable. So that means you can check where something is and search the network. We have mirror nodes, which is where that history is stored, and you're able to query that network for those transactions. A fork. So a blockchain fork is an event. So this happens on blockchains and chains in general where you might have disagreement in the community about how things should be done. And with Hedera, when we have the 27 members of the governing council, there's no forks. So it's because it's starting as a centralized sort of thing, and then moving towards decentralization, it's built to be not forked. So, but we do have that in other chains, like Bitcoin Cash exists, for instance, and Ethereum's gone through some forks as well. So, tokens and token gating. So if you're designing a user experience and you want to use a token for microtransactions, tokens can be all sorts of things. They could be like a badge or just different things like within your ecosystem. They're used in games, but they make it so you can have a gate for access to content. So that can be really helpful if you're trying to design an application where you want people to be able to get to things in a certain way, but you need to be able to monetize what you're doing. So it depends on how you want to set it up, but that is something that is part of this space too in Web3. Fungibility. So that means things can be exchanged one thing for another. They're the same thing, like the glasses in the picture, where they're all identical, and you can change from the one for the other. So a fungible token is something that you can do that with, like crude oil like that, or the glass, or a dollar, fiat dollar kind of thing, or a euro. Yeah, Bitcoin is always valued the same as another Bitcoin. Decentralized finance, so covered this a little bit earlier, where you've got the intermediary moved out of the way. So people can just connect directly with and share their financial information or whatever you want in that way with each other. So that's nice. Like I said, it helps distribute power more. A testnet, okay. So a testnet is an alternative to the blockchain used by developers, smart contracts before it goes live on mainnet. Mainnet is like putting it for public use. So you can put it on a testnet, and Hedera has a testnet and a mainnet. And so you can try it out there using testnet tokens. So there's just within a space, so it's like a place that you can experiment, try how things are working before you put it to live on mainnet. Public keys and private keys. So kind of like having an email address and a password. The public key is something that you share with others, and then the private key is something that helps you to log in. So you don't ever want to share your private key because once you do that, somebody would have access to your crypto, right? As they say, not your crypto, not your cash. Sorry. Okay, so much like at different ridges, depending on the manufacturer, different DLTs have different algorithms. So this is getting further into it, things here, where you can imagine, like, I've got locks at home for locking up the barn that have, it's called Master, that's the name of the company. Every company does it a little bit different. So a master lock, sometimes the key will fit in one, but not in the other from a different company, right? So each network does it in their own way. And there's some standards, like ECDSA. It took me a long time to be able to say that right, and I still messed it up. All right. But yeah, so ECDSA is a type of algorithm or that's used in cryptocurrencies like Bitcoin, Litecoin, and Dogecoin. It's common. And then we also have EDDSA, which is modern, so it's more updated, it's newer. They don't really, you can't use one for the other. So the locks, the keys don't fit in those locks. So you got to use the right one for the right circumstance. Thankfully, Hedera offers both. So you'd be able to do each one in its own way, the places that make the most sense. So if you need smart contracts, then you want to be able to use the ECDSA. Okay. So that's just something that is important to know, and you pick up as you go throughout this space. There's a lot of terminology, as you can see. So, okay, interoperability. So this is really nice. So in the same way that if you got the right keys and everything's matching like that, you can build your smart contracts on a network like Ethereum. And because we have the Ethereum virtual machine, as I was mentioning earlier, you have interoperability. So this is ideally, long run, I think which would be the most amazing thing for this space is that a user could move between different networks like this and take their data with them. Because then that way, if you weren't happy at one place, you could just move to another place and be able to be in control of your own data. So that's something that I find really empowering and something that I'd like to see for more kind of tools and technologies out there. So I'm a big fan of that, and interoperability helps. There's the Ethereum virtual machine, as I was mentioning earlier. So it is EVM compatible, Hedera, and we are working towards EVM equivalence. So essentially, we're on the way. So compatibility means it is coming along. There's some things that need to be jazzed up, I guess, so to speak. That's probably not the right developer term, but in time, we're moving towards EVM equivalence. So you can bring your Solidity contracts over and be able to work in our space with that. So yeah, that's really nice to be able to do that and know that that's there for you, because you don't want to be kind of locked in one space necessarily. You can come, you can develop things, and then if you need to, you can move elsewhere. So that's nice, because I know that's a concern for devs who want to be able to, not be locked in, right? Cryptocurrency wallets. So the wallets are essentially how you log in. So that you have your keys from earlier, and that phrase, not your keys, not your coins, comes up. But yeah, so there's lots of different types of wallets. You can get one like on a USB stick. So that would be like a ledger, which is a kind of cold wallet, stores it offline. And then there's hardware wallets, hot wallets. There's even paper wallets. So paper wallets is when you basically have your information for login on a piece of paper. So you can do that too. There's different ways to do it. Some people even use a like metal, and they grind it into the metal. So because it's something you could have for your lifetime. So it just depends on what you want to do. Yeah, and then different exchanges will have their own wallets, custodial wallets that you can use too for exchanges there. So on Hedera, you can use cryptocurrency wallets for login. On Web3, that's normally like that. So we've got a few in our ecosystem that you can use and that your users could use too, which is really nice to be able to opt into that. The Blade and Hashpack are very Web 2 friendly experiences. So if you've got users who are less familiar with this space than setting up MetaMask, they'd be able to join in that way. Smart contracts. All right. So as shown by the cute little eyes and the graduation cap, this is a contract which is clearly very intelligent. So they are essentially programs that are tamper-proof, and they run on their own. So you'd be able to run something on the chain that would be triggered by something, and then it would be able to keep things going. So it's a way to automate different states and sets of logic within the network. So there's smart contracts within Web3 in general, and they can be really helpful to keep things moving in a way that's easy. And like I said, you can port them across. So yeah, all right. Spoiler, you can integrate or start using Web3 TLCs without the need of smart contracts by using the Hedera SDK. So smart contracts in general are written in Solidity, which is a language that's based on JavaScript and C++. So if you're looking to learn that, that can be a good language in this space for sure. But with Hedera, you don't have to do that. You can use the token service, or HTS, and the consensus service together. So, but like I said, it's not limited to that. If you do know Solidity already, then you can use Truffle, Hardhat, and Foundry with your smart contracts. So a lot's possible with that. We try to make things flexible for Web 2 and Web 3 devs, because we want to be able to bring more people in to this space and help things out, move things forward. Solidity itself, like I was saying, influenced by C++, Python, and JavaScript. So if you're familiar with those languages, that'll help coming into this. I'm learning JavaScript now. So that is something that, in long term, I want to learn Solidity. But I got to get the basics down first. So like I said, I come at this from being an educator and teaching kids and adults in the past. So I want to make things easy for people. So yeah, it's nice to see that things are based on other things, because it makes you feel less scared to try it out, right? So, whoops. And the smart contract service, EVM compatible, like I was saying. So we have that all there. And if you've got familiarity with smart contracts on Ethereum, then yeah, you're in a good place. Web3.js and Ethers.js. So these are both JavaScript libraries that are used within this space that you can use to get started building smart contracts. So that's a really nice way to start. You can use the JSON RPC relay, which we have, to build things on Hedera as well. So it's not like you have to come in and be working blind. And yeah, so we want to make sure that this is a space that's friendly to all developers using JavaScript libraries. Oh, I have to be at the booth soon. I think that's up on the screen. It is, yeah. But yeah, so essentially, jargon, there's a lot of it in this space. And it can be really confusing. And I'm trying to make it a bit better. So hopefully this has helped today for you. And if not, please ask questions through the app, or I'll be around at the booth as well. Clearly, in a couple minutes, as the Google Calendar thing just went off. So we've got 30 seconds left. And yeah, so a Web3 developer, the last definition here is a developer who uses Web3 developer tools. That's it. So what's a Web3 developer? Essentially, it's you. If you want to be, you can just try it out. Yeah, it's all open source. You just dig in when it feels good for you. And yeah, that's about it.
Thank you very much, Ryan. We have literally zero time for questions.
I figured.
I can suggest you to reach out directly to Ryan, even out of stage or at the booth. You're having a booth, right?
Yep.
So because now the time is up, but thank you very much. That was a lovely presentation. And we are having a 10 minutes break, and in 10 minutes there is going to be our next talk about Web 3.0.
Yes, and that'll be with my colleague Ed, who's going to talk about the myths of Web 3. So from Hedera too. So stick around for that.
Yeah. Thank you, everybody.